So in this video, we'll see about electric field strength at various points due to charged metal sphere. So the metal sphere means conducting medium, conducting. So in case of a metal sphere, that is conducting sphere, you must remember one important point is that if any charge is supplied, charge will be distributed onto the surface, will stay on the surface. So charge flow takes place, and finally total charge will be distributed on the surface, and no charge will be there inside the metal surface. Okay, so here a metal sphere is taken and the q charge is given to the metal sphere, and total charge is distributed on the surface of this sphere uniformly. And here the charge density of this sphere you can take as rho, and generally the definition is charge per unit volume you can take, that is q by 4 by 3 pi r cube. So r is the radius of the conductor, radius of the sphere. So this is r. Okay, radius of the sphere. So at any point P, so at a point P on the axis of the sphere at a distance x from the origin to that point P, what is the electric field intensity? We'll see. See, the direction of electric field intensity is how much? To find it, see here another important point you should assume is, even though it is a sphere, and we have to assume that the total charge is concentrated at center O with respect to this point P, which is external, which is greater than radius of the sphere. So at this point the electric field intensity is just due to the charge at O. It will be, that is, the electric field acts in the direction along the axis of the sphere. Okay, this is the direction of E bar. So here let us write the equation. The case one is x is greater than r. Then what is the electric field intensity at x is greater than r is a q by distance square, that is x square, according to Coulomb's inverse square law. Here k is 1 by 4 pi epsilon naught. Now we'll see second case. If you take point P on surface of the sphere, that is at a distance r from the origin, on surface of the sphere. So the second case is x is equal to r, and the electric field intensity at x is equal to r is kq by r square, because even though you take on the sphere, on the surface of the sphere, for that, with respect to that also you can assume the charge is at center and the distance between them is r. So this value will be maximum comparative to any distance greater than radius. And what third case, inside the sphere, that is x is less than r. So x is equal to 0 or less than r, both we can take here. X is less than r is 0. What is the reason? Q inside the sphere is 0. So let us see how the electric field is varying from center of the sphere to at any point on the axis of the sphere greater than radius of the sphere. Okay, as we move from center of the sphere to at any point greater than the radius of the sphere, how electric field intensity varies, we'll see graphically. So here on x-axis, let us take the distance along the axis of the sphere, and on y-axis let us take the electric field strength. So at x is equal to 0, that is at the center, what is the value of electric field intensity? 0 only. And any region between 0 to r, that is on the surface, less than r, between 0 to up to r, not on surface, less than r. So between 0 to r, that is you can write like this, between 0 to r, square bracket, between this 0 and r, 0 is included, r is not included. What is the electric field intensity here? 0 only. That means what? The graph, if you draw, and this traces up to here from 0 to r. But what is happening at x equal to r? It is becoming maximum. So after reaching to the surface of the sphere, onto the surface of the sphere, the value becomes maximum. So this So at x equal to r, this value becomes maximum. And after that, greater than x equal to r, so after crossing the sphere greater than x equal to r, see how it is varying from this equation. Electric field intensity is varying inversely proportional to square of the distance between them. So graph follows this path. This is the inversely proportional to distance square. Clear? So in this you can understand how electric field is varying along the axis of a uniformly charged metal or conducting sphere. So next video we'll see by taking non-conducting sphere.